In this video, I'd like to talk about the math question of the day for March 2nd, 2023. And for this problem, we need to find the average value of the cosine function on this interval from an x value of -2 to an x value of 7. So to answer a question like this, you do need to understand calculus, particularly integral calculus. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted this problem, we can go through this together. And if you do have suggestions for future questions of the day, feel free to leave those as a comment. Now, when finding the average value of a function, we do have a formula that we can use that looks like this. And essentially, we need to take an integral over the function between those endpoints. We can call this a and that b. And then once we take that integral, we divide by the difference of the interval. Or essentially, we divide by the length of that interval, and that will tell us the average value of the function. Now, you want to be careful here, since you don't want to just memorize a function or a formula like this. You want to understand where it comes from. So let me quickly draw a coordinate plane. And let's say we have some random function on this coordinate plane. We can say it looks something like this. We can call it g of x. And remember that the integral from a to b will essentially calculate the area underneath this curve between this interval. So the integral from a to b of g of x dx, this is the area under the curve. We can call that a if we want. And once we understand that the integral of this function between a and b just gives us the area underneath the curve on this interval from a to b, we can draw some conclusions. One is that this area, whatever it is, can be transformed into the area of some rectangle. So this will be a little bit challenging to draw exactly, but let's say that we have a rectangle that maybe looks something like this. And again, this is not going to be that accurate of a drawing, so maybe I should make it a little bit smaller. Let's say that this rectangle here also has the same area as A. We can construct a rectangle that would have that exact same area. And we know how to find the area of a rectangle. It's just the base multiplied by the height. And in this case, the base of this rectangle, let me get out of that square tool. The base of this rectangle is just the interval length, which is b minus a. And the height of this rectangle would essentially be the average function value along this interval. So this height here is just equal to, we can say f average. It's the average function value along this interval here. Now, I won't rigorously prove this, but just to summarize, the general idea is that the integral from a to b of our function g of x gives the area underneath that curve, and we can call that a. But it's possible to construct a rectangle that has that same area a, where the base of the rectangle is b minus a, and its height is the average function value along this interval. And you can sort of see that. A function value right about here, this seems to be right in the middle of the highest value and the lowest value. And I didn't draw this perfectly, but that's the general idea, that the height of this rectangle would then be the average function value. And actually, I should be careful since we're using g here, so we can say this is the average of the function g. And since both of these areas are equal, the area of the blue rectangle and the area underneath this curve, this integral, we can set those equal to each other. We can say that the area of our rectangle, which is the average function value multiplied by the base here, this b minus a, and this is all equal to the area underneath the curve, which we know is just this integral from a to b of g of x dx. And to get this formula, we just divide each side by b minus a. So now that we understand where the formula comes from, let's apply it to our problem. And we can say that our function in this case is just the cosine of x, and a is -2 and b is 7. So we set up our formula that the average function value, the average value of the cosine function, is 1 divided by b minus a, which is 7 minus -2, multiplied by the integral from -2 to 7 of the function, which is cosine of x, multiplied by dx. And to take the integral of the cosine function is relatively straightforward. Its antiderivative is actually just the sine function. And this simplifies to 7 plus 2, which is 9. So we get 1/9 of the integral here. And like I mentioned, this integral has an antiderivative, which is the sine of x. And we're evaluating this between -2 and 7. So we plug in 7 first. We get the sine of 7. And we subtract the antiderivative evaluated at the lower bound. So we have the sine of -2. And this right here will be our final answer. And if we assume that our independent variable is in radians, we can plug this into the calculator and get an approximate answer since these are irrational numbers. And we get 0.174, and it's irrational, so it goes on forever, but we will approximate it to the thousandths place. So this right here is the average value of the cosine on this interval, meaning that on this particular interval, the cosine is slightly positive.